Please welcome back to the show our resident science expert, Kevin Delaney. Thank you for stopping by. Congratulations on the new show.
Thanks, man.
Tell everyone about Street Science.
Oh, it's a lot of fun. Street Science, it's a Science Channel Wednesdays at 10 and 10:30. I got a big team of artists, engineers, chemists. We go out on the street and we do some of our favorite science demonstrations. Big, small, lots of fun.
Yeah, I saw
cool.
something that involved toothpaste.
Yeah, we did our elephant toothpaste, or one of our old
Yeah.
favorites. We used a Volkswagen Bug instead of a regular flask, and
It went all over the place.
everywhere. Yeah, it got everywhere.
What are we doing tonight? Because they always do cool stuff.
So tonight we have liquid nitrogen,
Gotcha.
one of my favorite things. You know, really, really cold,
Yep.
minus 321 degrees Fahrenheit,
Yep.
Minus 196 Celsius, very freezing cold. So when you go outside and you get really, really cold, you forgot to wear your coat, what do?
I call for my limousine.
Yeah, you call for your limousine. But like William Henry Harrison, he was president for a few days, right? And he didn't wear a coat, and he got really, really cold. You go like this,
Yes,
right?
yeah, of
okay,
course,
so you
yeah.
huddle together. So carbon dioxide molecules behave in a very similar way. So the carbon dioxide molecules in this balloon are going to get really, really cold when we dunk it in liquid nitrogen. So go ahead.
Will it pop?
We'll find out.
Okay.
So go ahead and put it in there. You get your tongues. Yeah, don't worry. Just go ahead. And then you want to like push it down, like just let it get really, really cold.
It's like I'm sautéing.
And so what's happening is all the CO2 molecules are getting really close together and taking up a lot less space inside the balloon, and we end up with kind of like a gross, shriveled up orange balloon.
Oh, yeah.
Which I feel is a very appropriate image today. So you can go ahead. I don't know why they're clapping. We have things to do.
Yeah.
Okay, so go ahead and take it out, and so we'll see what happens.
So it's like a potato chip.
All those CO2 molecules can relax and warm
up
and expand and fill that balloon again.
Wait, so it just comes right back to...
Yeah, pretty much. I have more balloons over here. So go ahead and we can start pulling these out. These are the blue ones and the pink ones.
Wait,
so,
you can just do this?
So you could do this. Some of them pop. Be careful. Be careful. It's a day full of surprises.
It really is. Thank you, Kevin.
No problem,
It
buddy.
certainly is. So look how much fun this is.
There's another one. There's a blue one.
You do this at kids. Yeah, you gotta be careful if you do this at kids' parties.
Yeah, you don't want to do this with your liquid nitrogen at home. Some of them have helium in them.
Oh, that's so rad.
Yeah, there you go.
So the helium stays in there too?
The helium, yeah, it gets a little less smaller than the carbon dioxide, but it works.
Oh, that's so rad.
All right, let's go. We got more stuff to do. You want to take off your blue gloves now?
Gotcha, buddy, gotcha. What do we got here?
So now we're going to make a painting using some chemicals.
I love paint.
So you ever use a glow stick?
Dude, I go to a rave every other week.
Right on, yeah. So glow sticks work. You know how it works? You have to crack it first, right?
Yeah, but I don't understand what it does.
Inside, there's a little capsule filled with a chemical. It's called phenyl oxalate ester. Repeat that. No.
Phenyl oxalate ester?
Good job. Good job. Okay. So, yeah. That was great.
I'm listening.
It takes a long time to learn that kind of thing. Okay, so phenyl oxalate ester mixes with the hydrogen peroxide, that's the rest of the liquid, and the dye. And what happens is all the electrons in the dye molecules get really, really excited, and they, their energy level goes up like this, and then as it relaxes, it gives off light. It's called chemiluminescence, right?
Ooh, yeah.
Okay, so now, this is what we're going to do. Take these bottles here.
Okay.
You've got 1, 2, 3.
Yep.
And you just kind of pour them out here. Okay. And we can bring the lights down a little bit, too. Because what we're going to do next is take our hydrogen peroxide.
I'm not going to get used to that.
Okay, go ahead. You got your last bottle of dye there?
Oh, yeah.
There you go. There you go. Now we've got your hydrogen peroxide. So you're going to pour this on the count of 3. We're going to pour it slowly, and we're going to watch the reaction. Are you all ready?
Here we go.
All right, check it out. We're going to make a little painting here. That's pretty nice.
Dude, this is
there you go. And now, Jimmy, you got a paintbrush over here.
Wow.
So just paint your feelings.
This is paint my feelings.
Yeah.
This is so rad.
It's art therapy.
Dude, we gotta go to Bonnaroo together.
Yeah,
I mean, we really have to figure that out.
Yeah. I'll check my calendar.
I love this. No, I get it.
Isn't that pretty? All right, but we got more stuff to do. So let's put these brushes down here in these little tubs.
All right, Kim.
All right, and come around to the front.
Yes.
I'm gonna need some help. Can I ask the Roots to help me out with this one? Come on, guys.
Hey, boy.
All right, so now...
You snuck out of this one, man. Yeah, exactly. You're smart.
Now we're going to light the greatest band in the world on fire. Sound good?
Okay, yeah, that sounds fantastic.
So we've got these buckets here. In bucket 1, we have soapy water. In bucket 2, we have soap and water and butane. So butane's flammable, right? So this is what we're going to do. You want to dunk your hand into bucket number 1 and then scoop up bucket number 2.
Okay.
Okay.
Here we go.
So go ahead.
Yep.
Now, Brian's going to come in and kind of check your bubble levels and make sure everything's cool.
Yep.
And you don't want any bubbles on the bottom of your hand because they're going to light on fire.
That's
right?
not a
You
good
want to
thing.
know where the fire's going to be.
Yep,
so go
not
ahead
a good thing.
and scoop them up. Here we go. There we go. Now, everybody kind of line up here. We call this a line of fire. So, yeah, that should be all right. So, all right, everybody. Stay confident. And stay still, too. You want to make sure your hand is nice and flat like a table. And come in together, guys. All right.
All right.
All right, and don't try this at home.
Don't try this at home. What is going to...
Don't try this
like
at home.
soapy bubbles. I don't
It's
know what's
soapy bubbles. So all of our bubbles are connected, so I'm going to light them on fire. Are you guys ready? 3, 2, 1.
I smell burnt hair. I smell burnt hair. Is that you? That's Kamal. Kamal burnt his hair. Can we see that again in slow motion? Look at this thing.
There you go.
That's awesome!
And the soapy water was what did it. The soapy water gave you a little layer of water vapor that protected your skin from the fire.
You're the coolest ever. Kevin, always good to see you, buddy. What are we doing today? I got some fun stuff.
We do. We're going to be talking about force. And when I say force, I mean like a push or a pull that creates a change in the motion of an object, okay? So, Jimmy, you're an object. So...
Thank you.
The force of gravity, yes.
Thank
the force of gravity is keeping you on the ground right now. But if we want to do something like go to the moon, we need a force to propel us away from Earth.
Are you going to propel me somewhere?
Well, no. But,
Okay,
since I came from Little Rock, I brought a little rocket. So we have a little rocket.
Okay.
So most rockets, operate under a combustion that creates high-pressure, hot gases that push the rocket up, right?
Sure.
So we're going to create the similar effect using liquid nitrogen. So we're going to allow liquid nitrogen to boil. So nitrogen, as a gas, makes up around 80% of the air that you feel when you do this, when you wave your hands back and forth.
I knew that.
All right. But what we're going to do, we're going to observe liquid nitrogen, which takes up a lot less space, and it's really cold.
Yeah.
So we're going to boil it. The boiling point of liquid nitrogen is around minus 321 degrees Fahrenheit.
So what will it do when it... Well, I guess
We'll find out. We'll find out. All right. So you're going to pour the nitrogen into this bottle. Okay. And I've got the funnel here.
Okay.
So go ahead and pour it in. I'll tell you when to stop.
Okay.
Oh, there you go. Yeah.
Am I doing
So
it?
this is about 4 out of 5 every molecules that you breathe in is nitrogen gas. So don't breathe any more in.
Am I not breathing that? I'm not breathing right now.
You don't sound like you are.
I don't.
All right, a little bit more, a little bit more.
Okay.
All right, and then we're good. We're good. All right, so now we're gonna pressurize this by putting a little bit of a cork on it, right? And then that should give us the propulsion that we need to get the rocket away from us.
Be careful.
So I'll be careful. Don't worry, I got a hammer. All right, there we go. So in just a couple of seconds, that pressure is gonna fire the rocket. You okay?
I thought it was going to go that way. Can we see that in slow motion? Look at this thing. But,
Wow.
Whoa. I wasn't that scared.
There you go.
I wasn't that scared.
That's pretty good.
I was acting for the audience, of course.
Yes, of course. And don't try this at home.
Of course, don't try it at home.
If you have liquid nitrogen at home, don't try it.
What is this thing now?
Put this on.
Okay.
Okay. It is 2016, Jimmy.
Yeah.
Hoverboards. Would you like to ride a hoverboard?
No.
Well, I brought a hoverboard.
Well, these are the ones that...
No. It's not one of the ones with the wheels, the popular Christmas toy that explodes very
Yes, that
suddenly.
one,
Not
yeah,
one of those.
I don't want to do
Come
that.
up this way.
All right, what do you got?
So my friends from Arcs Packs lent us the Hendo hoverboard right here.
Hey, guys.
So
nice to see you.
you have your helmet on, okay?
Yep.
So Kyle, you can go ahead and turn it on, and then we'll listen to it rev up. Now, this is hovering about an inch off the ground. This is not on wheels, Jimmy. This is just, there's, the floor beneath it.
How are these...
All right, so grab onto my shoulder. Go ahead and step up.
Okay.
Okay, there you go. Now, Kyle...
You can tell I'm a
and
boarder.
Sean are going to push you back and forth.
Okay.
All right, back and forth to the future.
Yes.
All right, so go ahead. Push them this way. So what's happening is each one of the hover engines is creating a dynamic magnetic field, right? That's causing the copper to become an electromagnet.
Okay.
And that magnetic field from the copper is polarizing against the hover engine, creating that sort of hover.
I want to get off.
Okay, you can get off. All right.
Thank you.
You've rescued Hill Valley. Good job. Okay.
I got to call Doc. Kyle, hurry up.
All right.
God.
And step off.
That's fantastic.
And now you've been on a hoverboard.
I just hovered. Buddy. Thank you.
Thank you, guys.
Wow,
Thank you, guys.
wow. That felt weird. That was wild.
It was pretty good. It was pretty good. And it didn't blow up.
It didn't, yeah,
Right.
but something's about to explode here.
Something is, yeah. So I brought some Alka-Seltzer.
Oh, yeah.
You remember Alka-Seltzer?
I had some before the show.
Pop,
Yeah,
pop,
absolutely.
fizz, all
Yeah.
that stuff. Okay, so Alka-Seltzer has a little bit of sodium bicarbonate and some citric acid in it. So we're going to cause a chemical reaction when we drop it into the water that creates a lot of carbon dioxide bubbles that build up a lot of gas. We're going to pressurize that gas and allow that canister to pop right up.
So it's just like a little, it's a film canister.
Just a film canister.
Okay.
Those are still around, I guess.
Sure.
All right. So there we go. So now all that carbon dioxide gas is going to build up a little bit of pressure, and that force is going to push the canister right up in the air. It's a little, yeah.
There you go.
Thank you very much.
No, I mean, that was what I'm talking about right there.
Right.
I thought that was enough.
Well, we have a few more.
Yeah.
Come on this way. Oh, and put on your hat. You have another hat to put.
Oh, I appreciate the hat.
Yeah, right.
Thank you.
So, Jimmy, we have
for the audience as well?
We have over 1,000 of these
1,000
on this table.
1,000 of these.
Yes.
Now, right now,
over 1,000.
So the Alka-Seltzer's on the bottom right now, yeah?
Right now, there's nothing going on. When we turn it upside down, the water's going to mix with the carbon dioxide, the sodium bicarbonate inside there, and it's going to,
Explode.
Okay.
This is really fun.
Ready?
All right, which way are we turning it?
Okay, we're going to turn it towards the audience, but hang on a second. I got to pull the pin. It's like a grenade.
Yep.
All right. So ready?
Push it down this way?
On the count of 3. 1, 2, 3. Yeah, down this way. Okay. And now, that reaction is happening. We made it look a little pretty for you. There you go.
Oh, hey, cool.
Yeah.
Ah, looks fantastic.
Yeah.
All right.
So in just a second, all of these little kind of bubbles are going to start building up the pressure that they need to move all those canisters up. So there was one.
Yeah.
Okay. So it's like popcorn. It takes a little bit of time. You got to wait. But it's kind of, it's an exciting reaction. There you go. And there's a few more. Now, try to catch some. See if you can catch any. You can use your hat if you want to. Now, they're going to keep going.
I don't know.
Because there's over 1,000 of them. So eventually...